Hi, everybody. So my name is Eric. My contact information is at the bottom here. It's great to say at the end of the presentation. Feel free to shoot me an email if you have any further questions, if you want to grab a coffee, whatever, chat over email. So I am a full-stack software developer. At this point, full-stack kind of isn't quite as clear of a meaning. Sort of depends on what technologies are in your stack, whether I actually do the whole thing. I think generally probably what it tends to mean at this point, and certainly what I mean by it, is that I work on the front end. I work on sort of the web API layer of the back end. So, that can be Node, that can be Django, Python, interacting with databases. When you get more into like the DevOps world, where you're working on server level infrastructure and scaling stuff up and automating your deployments and all that stuff, I have a lot of experience with that. So, the tech stack includes that, but I'm not quite full stack. My biggest area of expertise, though, is front end, more so than back end, and definitely JavaScript is the language I'm most comfortable with. I spent a lot of time writing Python as well. JavaScript is the one that I know the best. And so what I want to talk about today, as my title slide here says, is the JavaScript tooling ecosystem. I think that when I first set out to build this presentation, I imagined I was going to cover more technologies than I am. I just found that it's taking longer than I expected. So really, I'm not going, I think the phrase ecosystem is probably a little bit ambitious, and really want to talk about two main technologies, and that's Webpack and Babel. And when we talk about tooling, in general in programming, this is not just a JavaScript thing, it's not just a front-end thing. Tooling really refers to anything that makes you as a software developer more productive. So this could be software that helps you write code faster. It could be software that helps catch bugs for you before you even have to run your code yourself. And it could be software that kind of helps enforce a certain standard of coding. So if one person on your team likes to write code with like 50 line breaks between every single line of code, another person wants to write it all in the same line, there are tools that will help enforce a standard type of style. And there's one that's really gained a lot of traction. I'm not going to get into it today, but it's called Prettier. So that's for the JavaScript ecosystem. Prettier will reformat your entire code. It's wonderful. It might make some stylistic choices you don't like. That's the way I felt about it at first, and I was hesitant to give it a try. But once you start using it, you never have to format your code yourself ever again. It's beautiful. You can connect it so that when you commit to GitHub, it automatically formats it. It's really wonderful. I'm not going to get into it today, but there are great tutorials online, and I definitely recommend you check it out. When it comes to Webpack and Babel, really everywhere where JavaScript is written, and this is not just front-end code, this is back-end for Node as well, pretty much anyone writing JavaScript these days is going to be using these two technologies. There are certainly some exceptions to that, but I would say that especially when it comes to any kind of production-level code, these two technologies are definitely involved. Maybe on side projects, people don't want to bother with the additional work of getting things hooked up, and it's just a side project, so you don't use them, but definitely for production code, everywhere is using these things. And they've, as a result, really become a fundamental part of being a JavaScript developer. Years ago, there was no really JavaScript tooling. You just kind of like stuck your JavaScript in your HTML page and a web page, and it just ran. Whereas now, this tooling ecosystem is really, really critical. The other thing I want to say about this stuff before I dive in is that it can be confusing at first. It can be confusing. You can get kind of cryptic error messages. It's a little bit frustrating. You just want to get going. You just want to start writing code and build your app. And instead, you're stuck here trying to configure these tools before you can even really write a line of code. It kind of sucks. It's kind of annoying, but you will get it down. When you run into these errors, there's plenty of documentation online. Stack Overflow is your best friend. And once you start to get the hang of it, you'll be fine. It's sort of like a bit of a hurdle at first, but you'll ultimately get it, and then it'll just be a part of your workflow, and then it'll be fine. So let's go ahead and dive in. So one of the things that these tools do, sorry, formatting's not great, is code transformation. And so why is it that you'd want to actually have a tool transform your code? Well, one reason is, here, let me zoom in a bit since this seems not as big as I expected. So one reason that you might want your code to be transformed is that you actually want to use JavaScript that not all browsers understand. This is not the best example. Most browsers at this point understand this type of syntax. It's called object spread notation. It's for merging two objects together in JavaScript. Not too many years ago, browsers only understood this version. And still, to this day, if you need to support, maybe Internet Explorer 10, I think, might not know this. So depending on what types of browsers you need to support, you still might need to transform this particular thing into something else. As I said, it's not the best example since browsers do have a lot of support for this, but there are certainly newer examples that I use on a daily basis that you can't depend on as much on support for. And so one of the reasons you want to transform your code is so that you can write the newest, sexiest, hottest new JavaScript and have browsers actually understand it, because what gets sent to them is something different. Another reason to transform your code is perhaps you want to use something that is not actually JavaScript at all. So here we have an example of JSX. It's become very popular as a result of its use in React. This is not JavaScript. It's just a totally different thing that browsers have no idea what to do with and will totally throw an error. So transforming your code from this into actual JavaScript is another reason. Very common reason as well for shipping code to web browsers is you want to minify it. It just makes the file smaller to download, makes it look beautifully illegible like this as well. And again, all production apps at this point are going to be going through some kind of minification. And finally, this is what I was talking about when it comes to something like prettier and code formatting, right? So this is actually the exact same code. It would run perfectly in either case in the browser, runs identically, but in this case, we have it being formatted much more nicely, much more readable. And so that's yet another reason. There are also a wide range of other magical things that, of types of code transformation that you can do. You know, like one example that comes to mind, if you're familiar with SVGs as a form of image, they're actually code. SVGs are actually code. And if the SVG is embedded in the HTML, so rather than using like an image source tag, if you instead actually put the SVG code directly in the HTML, you can then style it with CSS. You can then even use JavaScript to animate it. But that's not actually possible if it's just an image tag with a source attribute pointing at an SVG image. In that case, you can't do anything with it. Now, when you're actually writing your code, it kind of, some SVGs get enormous. So it would actually suck to have to put all that inline SVG code right into your HTML document so you can then style it with CSS. So one thing that these tools can do is you can just put in the normal image source attribute, and then your tool can itself, when you actually go and build the final production code, can inline all of that SVG code so that then your styling does work. So that's just one example. There's a ton of other stuff out there. One of the most common of those tons of other stuff that's out there is something called module bundling. So this is what module bundling refers to is combining separate files into a single file. This is really critical when it comes to web software. Basically, it sort of accomplishes a couple different things. One, it allows you to write your code in different files, so you don't have to jam it all into one file itself. And it also can improve performance when it comes to actually downloading that file to the browser. So you might be aware, maybe not, that the speed of downloading files to a web page, it's not just about file size. In fact, one of the biggest parts that takes time is literally the actual request. The browser makes a request to the server and has to wait for a response. And that actually takes some time. Often that might take longer than the actual downloading of the file itself. So by combining stuff into a single file, what you can do is you can reduce the amount of requests that the browser has to make. And although it's going to have maybe the final file size is actually the same as what all these independent files would have been, the fact that it's just one request makes it faster. So if you guys have done work with Node, then you will already recognize this require syntax. So in Node, we don't have to worry about module bundling. There are still some cases where maybe it's good to do it for performance reasons, but in general, you just do it like this. You have it in separate files, you use this require call, and boom, now I've got access to this path variable, and I can call path.resolve or whatever else I need to do. Browsers do not understand this. Browsers don't have the ability to import other files. That's not 100% true. I don't want to get into the weeds on it, but browsers are increasingly starting to be able to support this kind of thing. But The browser support is not very strong yet, and as I mentioned, even with that browser support, since combining files into a single one can improve performance, even once browsers have 100% great support for this kind of dynamic importing of other files, it still might be advantageous, it still will be advantageous in a lot of cases to bundle. So still a totally relevant topic, even once browsers are fully moved into the future. So how do we bundle these files together? The main tool of choice is Webpack. There are some others out there that some, like, JavaScript library maintainers will use. I think one's called Parcel, maybe another one's called Rollup.js. I'm not quite sure what advantages they offer over Webpack. From my understanding, they have to do with just really making your code as just small as possible, reducing as much from it as possible. So if you're distributing it to a bunch of developers, it's not taking up as many bytes. But really, the name of the game at this point in the JavaScript ecosystem is Webpack. And so let's take a look at what Webpack looks like. Try to mirror my display here.
If you go to arrangement,
Yeah. Ooh, that's dark. I can make it lighter. All right, so.
Sorry, could you share your screen on the Google Hangout too? Sorry.
Oh, yes, this is, I see, got it, yes.
Great, thank you.
Okay. So here's a very basic JavaScript file to show you what the HTML looks like. Here we've just got a button with the ID of foo, another button with an ID of bar. They currently don't do anything. I'm ultimately trying to import a JavaScript file relative to this index.html file. I'm trying to import it from a JS folder that should be inside of this build folder. And then I'm trying to reference an app.js file. As you can see, that doesn't exist. That's because that file will get created by Webpack when I go ahead and do the module bundling. And so what my amazing app is going to do, you can see here I'm importing this bind button click function. So if we take a look at that, bind button click is taking an ID, and it is taking a function. It is finding the element with that ID, and then it is going to listen for click events on that element, and it's going to call whatever function was passed into it. And then in here, back in the index file, you can see I'm calling it twice, once with an ID of foo, another time with an ID of bar, and I'm giving it these functions, say foo, say bar. They're really incredible. They just log out foo, and they log out bar to the console. All right. So if we then take a look at Webpack, this is what my Webpack configuration file looks like. This is a very basic one. And this is really where all the Webpack magic happens. Let's actually take a step back and I'll look at my package.json file. And so if you guys aren't familiar with the package.json file, it's what starts to get created when you start using npm dependencies, or maybe use Yarn as your package manager. If you're not clear on that stuff, let's just chat afterwards. You can see I've installed Webpack and this Webpack CLI thing. Again, I don't even remember what I have to do to install Webpack. I go to webpack.com or wherever the URL is, I look at getting started, or I copy and paste from a previous project. I mean, that goes for this Webpack configuration file I'm going to show you as well. I don't have this stuff memorized. I literally go from the most recent project I built that has the same technologies I want to use, and I copy and paste and then kind of modify, and if I need something new, I go to the docs. It's hard to memorize because ideally you're not spending a lot of time with your Webpack configuration file. Hopefully you get it set up at the start of your project and you don't touch it for months. And maybe, I need something new. Maybe then I need to touch it again for 10, 15 minutes, and hopefully again, you just never look at it again. So I wouldn't expect you to commit any of it to memory. I certainly don't. I'm always kind of copying and pasting and going looking back to the docs. That's just sort of the nature of this type of thing. So you can see I defined my start script here. It's going to run the Webpack command, It's going to pass it this config flag, and it's going to point at webpack.config.js. I'll talk about this final -w in a moment. So it is where this webpack.config.js is referring to this file. And so Webpack is going to use this configuration object to figure out what it should do. So let's just talk about a couple of these things. Entry is essentially what file should Webpack start with. In this case, I am giving it the directory name of this folder /source/index.js. So it's ultimately pointing at this index.js file. What Webpack is going to do is that when it encounters, it's going to go to that entry point, and it is then just going to follow all of the require statements to decide what do I need to basically merge into a single file. So it gets to this folder, it gets to this file, it finds require bind button click, sweet. I'm going to make sure I grab all the code from bind button click and include that in the final bundle. If bind button click imported other stuff, it would then traverse into those other files and grab those and so on. And so, as you can imagine, a large JavaScript project is traversing, hundreds, if not thousands, of files and ultimately assembling them. And then we have this output object. Again, I would never remember what the actual keys are supposed to be in this output object. I just have to look back at what I did previously. File name, I guess it's going to be the file name of the final bundle file. Then the path is obviously going to be where it's going to snip that final file. As you can see, I'm going to stick it in build/js. It's going to be called app.js. So again, if we look back at this index file, that's something that we're looking for here is js/app.js. This dev tool module file name template, I guess that has to do with this dev tool key here, which says source map. I'm saying I guess because I just copied and pasted it. So source maps, if you're unfamiliar with them, are wonderful. They are absolutely critical when it comes to module bundling like this. They're amazing when it comes to actually minifying the code, because what it does is if there is an error, it is able to point, it allows the browser to, or whatever the ecosystem is that you're running it in, it can actually figure out where in your original code did that error occur. So rather than having to look into the finally built code, which might just be minified all into that totally unintelligible minification code, you can actually just go and look in your normal source code because it's been able to point to where that is. So for this kind of thing, source maps are just absolutely fundamental. Everybody uses them. Webpack makes it really easy. And then this resolve key, I am basically telling it these are the types of files you should pay attention to that you should bundle into my final JavaScript file. In this case, I'm saying pay attention to JavaScript files, and I'm saying pay attention to JSX files. The reason I have to give it these file extensions is that Webpack can also let you import stuff like SVG files into your JavaScript code, and then provide that as a source on an image tab, which just doesn't really make any actual sense when you think about actually JavaScript. How do you import an SVG file? It's SVG code, it's not JavaScript. And so in that case, Webpack will ignore that SVG file for the module bundling. And then, I'm not going to show it here, but there are other ways, other additional configuration options to give Webpack that tell it how to handle files that end in SVG when you're importing them. So this is enough to really get up and running with Webpack. These configuration files can get really big, they can get really complex. I don't know if any of you have used Create React App in order to start your React projects. So Create React App uses Webpack, among many other things. And it actually basically lets you get up and running with the React app for free. You don't have to do any Webpack configuration yourself. And Create React App, though, has an option called Eject that lets you then see, basically, rather than having Create React App do everything for you, it's going to essentially unbundle itself and put it all into your folder here so that you can then actually modify how it's working. And so if you ever want to see just some crazy Webpack stuff that nobody understands except for the people who make Create React App, you can go Create React App, Eject, and take a look at their Webpack stuff, and it's terrifying. The company I currently work at, we actually used Create React App to start, and then did Eject, and so it is terrifying, it is huge, but luckily I'm not the one who has to be an expert on it. Great, so enough talk, let's do this. So here I am in my examples folder. I'm going to go into that particular one. And then again, my script in order to run Webpack on it is just my npm start here. I use yarn as a package manager. It's more or less the same. So I'm going to do yarn start. Great, it's done. So you can see the output for Webpack. It tells you the final file size. This .js.map is the source map file that it generated, so you can see where the errors actually are in our code. It shows you the files that actually got bundled together. In general, you don't need to really pay attention to this output. You see a bunch of green, and so you know, sweet, it worked. If you see a bunch of red, then it's probably something went wrong. It didn't work. This -W flag here, what that stands for is watch. So one of the awesome things about Webpack is it's actually going to watch for file changes and rebundle itself as necessary. So I don't have to keep running Webpack every time I wanted to try my code in the browser or wherever. It's going to automatically do it for me. So if I just come in here, console log, hello. It's going to happen really fast, so let's compare the file size to be sure that we see it happen. So 4.75 kilobits. Go back. Oh, there it is. Still preserved it. So you can see it now. Ran it again. Weird.
What's your answer?
It's my wife. Sorry. Let me figure out how to get that stopped. Shoot, I think I just closed the Hangout.
It's okay.
So I have no idea where that thing is. All right, well, she gave up. You mean
Okay. That's me.
that's the Hangout. Share screen. All right, we got it.
Oh, you didn't share the screen. Oh, that's sorry. Yeah, there you go. And then you have to hit share screen on that window. There you go.
Back in business.
Yes.
All right, that was exciting. Great. So what happened was I made a change. Webpack automatically rebuilt it. Tells me the new file size. Awesome. One thing is you get in Create React app, it comes bundled with something called Webpack Development Server. So what that will do is if you're coding for the browser, it'll actually refresh your browser page. There's other crazy stuff called like hot module reloading, which works a lot of the time, sometimes doesn't work great. And what that can do is it can actually inject new JavaScript code into your page without even refreshing. So if you're like building a React app and you change one component, it can just like change that component in your browser without actually having to refresh everything. Totally crazy. And so the other thing that using Webpack gets you as well, which newer, I think experimental versions of Node are starting to support, and it's where Node is going to, is just simply a different syntax for requiring stuff. So instead, you would do import, bind button click from that. It's exactly the same. If you're using Webpack, you should just use this syntax because it is where things are going. I don't think require is going away anytime soon, but it will eventually. All right, so that is a quick intro to Webpack. So let me go back to presentation. All right. So that is Webpack as a module bundler. And actually, you know what? I wanted to show you really quickly. Let's take a look actually at what that file looks like. So here is the final bundled Webpack file. Since it can look a lot more cryptic than this if you were using minification. In this case, we're not minifying it, so you can see here's actually like the code that I wrote. Webpack, without minifying it, also kind of provides you with these really helpful comments to help you see which file it came from. So there are times when like your source map might actually fail, and then being able to see kind of this big comment can help you figure out where the error might have arose. You can see then there's a bunch of other stuff up top here that Webpack just generates. I don't know what it's doing. You don't need to know either. All right, so that is Webpack. Now let's talk about Babel. So Babel, as it says here, is a JavaScript compiler. So when I gave you that example of that object spread notation that gets transformed into object.assign, Babel is the thing that would do that. Here are some better examples of things that Babel can do. This object shorthand notation, the method name, it can transform that into JavaScript that actually the browser understands. Yeah, it transforms to React, all that stuff. So let's take a quick look at an example with Babel. Close all this stuff. Save that. Great, so here's an example of using that, using something called, I don't know, object spread, rest parameters, something like that. Essentially, what this notation is doing is it's saying, from this object ocean that has these keys temperature, color, and jellyfish, I want to create a new variable called temperature that is going to basically, in this case, equal 83. And then I want you to create a new object with all the remaining keys and put that in a variable called remaining ocean data. So at this point, temperature is going to equal 83, and then remaining ocean data is going to equal color, aquamarine, and jellyfish, lots. All right. It's really nice syntax for just kind of pulling objects apart and creating new variables out of them. Again, I think browser support for this is now actually pretty solid. Again, pretty sure IE10 probably would not support it. All right, so the way that Babel works is with something called plugins. So here I've installed some Babel dependencies, and then I've got a script called no plugins that's just going to run the main Babel command on that index.js file. All right? And so what we're going to see here is that actually nothing is going to happen because Babel by itself doesn't do anything. You have to tell Babel what plugins you want to use in order to transform your code. So close down Webpack there. So no plugins. What it's going to do is I'm not having it write to any files. It's just going to output what the result would be if I wanted to turn it into a file. Oh, I lied. 1 second. Right, ignore what just happened. This is what was supposed to happen. All right, it looks exactly the same, right? It didn't actually turn this into anything different. We still got this ... etc. So as I said, Babel works by plugins. So here I've got my with plugins script, and I'm specifying in the plugins flag that I want to use the plugin proposal object rest spread. And the Babel website has explanations for what all of these different plugins do. So if I go back to my console, with plugins, whoa, now we got a whole bunch of other stuff. And so you can see here now it's kind of creating this const temperature equals ocean, the remaining ocean data, it's calling this function object without properties on it. And where does that function come from? Well, Babel has that function and sticks it right into your code so it can actually then use it. The most common way that you use Babel is not with these command line arguments specifying the plugins. Instead, the most common way is with a babel.rc file, like that, where you define your configuration. So here, the babel.rc file takes a key of plugins and takes then an array of which plugins you want to use. There's some other keys as well, such as presets that you can look up and that you end up using. And so if I have a babel.rc file present, then this no plugin script will just automatically find it. Even though I'm not specifying plugins here, by having a babel.rc file, it will automatically find it. And that's why the first time I actually ran it, when I had intended it not to do anything, it still did. All right, there you go. It stuck this whole object without properties blob into the code. All right, so Similar to Webpack, we don't want to have to like run Webpack build every single time we want to bundle all our modules together. Same with that, we don't want to have to run Babel on every single time we want to transform our code into something that browsers can use. Unlike Webpack, though, Babel does not come with a watch mode. So how do we get Babel to do its thing every time a file changes? Well, the answer to that is we use Babel with Webpack. And so Webpack really ends up being this sort of like orchestration tool for a lot of other tools. A lot of other tools that basically get run by Webpack. Webpack handles paying attention to files changing and then handles kind of like distributing the work of what should do what to which file based on what it encounters. So let's take another look at this Webpack configuration file now. And so far, it's pretty much similar. Entry, again, which files are going to start out with, looking for those require statements. Output, we're going to as well output that to app.js. Still resolving the same types of extensions, JS and JSX. But now here is the difference. So if we take a look back at my very first Webpack file, this is pretty much all exactly the same. The difference is I now have this module key with rules inside of it. And so what rules is doing is it provides a test key, which is just a regular expression saying that this rule should apply anytime you encounter a file that matches this pattern. So going back to that SVG example, if we wanted to process SVGs in some special way, we would have a test that would probably be something like SVG. And then we would tell it to use some kind of SVG loader type of thing. In this case, though, we still want to handle JavaScript or JS and JSX files. We want to exclude anything inside the Node modules directory. In general, the stuff that you're getting from the Node modules directory should already be transformed in the way that when you actually import it. And then we are using this Babel loader. And where does this Babel loader come from? It feels a little magical because it seems to just be giving it a string, Babel loader. Webpack will, under the hood, take a look in your Node modules directory for it. And so that's why my package.json file here, it's the wrong folder. My package.json file here, you can see I do have Babel loader installed. So if we then take a look at my Babel RC file, here I've got plugin transform react-jsx, plugin proposal class properties, and this Lodash plugin. So just 3 different plugins than what we saw before. The reason I've got transform react-jsx is that in my app here, I'm actually got some React code, and it needs to transform to JSX. So let's go and just run that. So here we go. Webpack is watching the files. It's gone ahead and output it. And then just like before, if I start making changes to this, Webpack, we didn't see it because it happened so fast, but we now have the second build output here. So that shows that Webpack did rebuild it. And it's using Babel. We know it's using Babel because Webpack does not understand JSX. Webpack itself it doesn't transform stuff. So in fact, if I take this off, just comment this out. I'm going to have to restart Webpack. If you make a change to your other Webpack and look for changes in all your other files, if you make a change to the Webpack configuration file, you're going to have to restart Webpack. So now if I run that without the JSX, without the Babel plugin, now we get an error. And here it's pointing specifically to this bit of JSX code here. Webpack has no idea. All right? So let's actually take a look at just what this app is doing. Oh, there we go. Just open that in the browser. All right. So change that bit state. Count 1. So here I've got a React component. I know this is not a talk on React, but just so that we can follow what's happening here really quickly. Basically, this React component maintains a count, and it's got a button down here that anytime we click that button, we're going to run this make more amazing function. All that function is going to do is it's going to basically say make the count, whatever the previous count was, plus 1. And then what I'm ultimately doing with that count is I'm calling using this function repeat from the library Lodash, which some of you might be aware of. And all that's going to do is it's going to multiply the letter z. It's just going to repeat the letter z by the count. Right? So if I, oops, as it didn't rebuild for some reason. Okay. All right. So here we go. I'm amazing. Make more amazing. We're just adding keys. All right. So there's one other thing I wanted to point out here about what's cool with Webpack and Babel plugins. And so that is that one of the plugins I have included here, is called Lodash. All right. So Lodash, if you're not familiar with it, is probably surely the most popular, just kind of all-purpose utility library for JavaScript. So that function repeat, it's got a whole bunch of other functions in order to like merge arrays in special ways, or to find just unique items in arrays, just all sorts of just small little utilities you might need. So Lodash is a very common library people will include. However, in this case, as you can see, all I'm using is the repeat function. So it's kind of a drag if I'm going to include the entire library just to use this one function. So what this Lodash plugin is doing is it is getting rid of all the other Lodash code that I'm not actually using. And so to prove that, I can remove this function, or remove this plugin. And so if we see here, the last time the app built, it was 1.39 megabytes. So now that I have removed that plugin, what we're going to see here it is still 1.39 megabytes. Well, why did that happen? Very strange. The dangers of live coding, you know? Weird. I wonder if actually it could be that this is not the right thing to have here. I wonder if I should be calling it plugin Lodash. Nope, can't find it. That's the right thing. Anyway, not quite sure what's going on here, but in theory, there's a way to have it essentially exclude all Lodash that you're not using. And maybe I just don't have it wired up correctly here. Oh, there we go. Now it's down to 9.17 kilobytes for some reason. If I remove that, oh. I know what happened. When I removed it, it automatically rebuilt it. So when I looked at the original size, so here's with it in, it's 917 kilobytes. Now if I remove it, there, now we're seeing the 1.39 megabytes, right? So this jumped up nearly 0.4 megabytes. So you can imagine there are other libraries as well that you want to do the same thing to. So this technology is called tree shaking, just a little vocabulary word. It's basically, it tries to figure out what code is actually being used, stuff that isn't being used, just discard it. So that's pretty sweet. All right, so that is pretty much it. I was hoping to also talk about ESLint is maybe something you guys have heard about. What ESLint does is it kind of like, it can catch errors in your code, it can enforce styling, and as I mentioned before, there's Prettier as well, which does a lot of formatting. These are 4 tools, Babel, Webpack, ESLint, Prettier, that are really commonly used in the JavaScript ecosystem. And along with like doing cool stuff like this and making your code more performant, once you get this stuff wired up correctly, it actually creates a better developer experience. So there's a little bit of investment up front just to get it all working smoothly together, but once you do, it really pays off. It makes it a lot nicer to code as a developer. Maybe a couple other technologies I'll throw out there as well that this stuff gets used with, especially if you have done work with Angular, then perhaps you're aware of TypeScript. There's also something called Flow that's released by React, and so what TypeScript and Flow are is they provide typing for your JavaScript. So some languages like Java, you actually have to specify what the type of every variable is. This is a string, this is a number, this is an array of strings. And that can be kind of annoying for some people, but it can also provide your editor, like VS Code, with a lot more information about what's going on. And it can allow you to then actually catch bugs before you even run your code. So you can say this function takes an argument that should be a string. And if somewhere else in your code you're calling that function with a 1 in it, you don't even have to run your code. Your TypeScript or Flow tooling is going to tell you you have an error here. And so between that and like having test coverage, you can do giant code refactors that without them I just never would even try. So that's pretty sweet. And those typings, again, are things that the browser doesn't understand, so they need to be stripped out. And so Webpack in combination with Babel are what will allow you to remove that stuff. So I think that's it. I'm happy to stick around and answer questions. Yeah, thanks guys for being here.
Thank you.
Yeah.
So Babel, its main purpose, I mean, from my understanding, is it to transform?
Yep. It's going to take the code you give it, and it's going to give you some different code on the other side. Yep. All right, cool.